Now we're talking about complex ions today. We talked about color at different points, like does a particular complex have color for basing it on the electron configuration. Now each one of these beakers that we have here has nickel sulfate hexahydrate in it plus 150 milliliters of water. You can see we have a nice pretty green color. But what we can do is we can change the ligands that actually are attached to it. So what I'm going to do, the first one, I'm just going to leave as a reference so you can see how the color changes. So that's just the nickel sulfate hexahydrate and 150 milliliters of water. The next one what I'm going to do is I'm going to add some ammonia to this. I'm going to add, let's see how much do I want to add. I'm going to add 20 milliliters of this. It's a pretty powerful smell to this, of course, we know. Alright, so this one here, I'm going to add the ammonia, mix it up a little bit. And we got a nice kind of bluish color solution, so I'll leave that here. So that's ammonia. And I'll write the reaction here that we're doing. So we have the nickel compound with the 6 waters. This is the actual complex ion itself. The sulfate is really just a spectator. We don't really care about that here. And then we add NH3 to it, and we get NH3, 6, 2 plus, and then the waters are removed. All right, so this is a nice blue color here. So that's what we get. So the first one was just the way it was, and then we have the blue color. All right. Now the next thing I'm going to do, I'm going to use ethylenediamine. That's one of our bidentate ligands, and I'm going to add just different amounts. So I have 3 beakers here. This first one I'm going to add somewhere around 2.5 milliliters. I mean, the exact amount is not too critical. So I'll do that. Let me add 2.5 milliliters. Let's see what we get. I may have to add a little bit more to get the exact color. All right, so put that up here. And then mix this up. So we have a light blue color. It does look different than, obviously, this guy does. That's our light blue color. And the reaction we have there, again, this is an octahedral complex because we got 6 ligands there. So again, starting out with the same compound, we're adding ethylenediamine, and this is what we get. And then 2 waters. Now it's still an octahedral complex, and we get kind of a light blue color here, as I mentioned. Ethylenediamine bidentate, so that means we get an octahedral complex. All right, so next beaker over, let me add a little bit more. We'll add about 5 milliliters, again, plus or minus a little bit. Being real critical here. Let's see what we get with this one. So we can see we have a different color. We get the light blue, and then we have a darker blue, not as dark as the ammonia was. All right, so now, same idea here, still starting out, same compound. And now we're 2 in, because essentially I'm doubling it. I have 5 versus 2. I'll write the gloves on here on the chalkboard. So we have NiH2O2, En2, 2 plus, and 4 waters. So that's what we get with that. Now this one's a, let's call it a blue color versus light blue. All right. Now the next one over, I'm going to add 7.5 mils or so. Let's see what we get. There we go, a nice kind of purple looking color. Alright, reaction for that. Well, again, we have same starting compound. Now this will be 3En. So we have NiH2O, En3, 2 plus, and 6 waters. This is a purple color. What's that? Got one more. Now this one's going to be a different complex. Again, this is just like this one above here. This was octahedral. This is octahedral. I have a different ligand now, dimethylglyoxime, that's what they call it. And I need to add, again we're starting out with a green color, I add 12.5 milliliters of that ligand, give or take. And let's see what we get here. Ooh, that's nice, I like that. So we get this red precipitate here. Alice, this is really like a Christmas reaction if you like the traditional red and green colors. Now eventually, this will all settle down here. I'm going to just stir it first just to mix it in, but later on after you'll see that it does actually. And we're going to have here, this is what actually happens, they call it 2-DMG, dimethylglyoxime. And you get NiDMG, and this is red in color. It gets 6 waters. There's actually some hydrogen here too, plus 2H plus. This actually is a square planar complex. So with all this, all I do is I just change the ligands. You're taking some off, putting something on. So you can change the color just by whatever ligand type you have.